Howdy, 6th grade. Good morning. Today we're doing lesson 7.6, which is that I want you to be able to solve inequalities using addition and subtraction. This is really not too bad. First, let's take an inequality that's fairly obvious. 5 is less than 10. 5 is less than 10. This is a true statement. Now what I'm going to do is I'm going to add the same number to both sides. So I added 2 to both sides. 5 plus 2 is 7. Is 7 still less than 10 plus 2, which is 12? Well, what do you know it is? Okay. But what if I add a big number, like 15, to both sides? 7 plus 15 is carry the 8, 22, and this is 27. Well, jolly gee, it looks like if we add the same number to both sides, this inequality is going to stay the same. I'm sure that's just a coincidence. Let's try another one. Negative 5 is greater than negative 10. What if I subtract 3 from both sides? Oh, that should have been in red. Oh well. If I subtract 3 from both sides, negative 5 minus 3 is negative 8. Is negative 8 still greater than negative 13? Wow! And what if I then subtract 20 from both sides? This is negative 28. This is negative 33. Oh my goodness, it's still the same. Okay, this leads us to our first thing that I want you to know. Addition and subtraction properties of inequalities. Here it is. When you add or subtract the same number to both sides of an inequality, the inequality remains true. If you add or subtract the same number to both sides of an inequality, the inequality remains true. Okay. And obviously this would hold for any inequality symbols that we had. Less than, greater than, less than or equal to, greater than or equal to. Okay. So we're going to do something called solving. We've done this already. Inequalities. We've done this already with equations, and I'm going to give you a reminder. X plus 3 equals 7. We can solve this equation by subtracting 3 from both sides, and we get that x is equal to 4. Or if we had x minus 4, there's a hole that's 4 deep. Well, we can add 4 to both sides, and we get that x is equal to 12. These are the properties of addition for an equation. It's the same way of solving for inequalities. So let's do a couple of examples here. All right, example 1. We have x plus 4 is greater than 2. Okay. So we have some number x that when we add 4 to it is strictly greater than 2? Well, the same question that for equations that I had you ask for equations applies here. What is happening to x, and how do we reverse it? This is our key. What's happening to x is it's being added by 4. So let's subtract by 4. We had x plus 4 greater than 2. We're going to subtract 4 from both sides. And we had this 4 pebbles on this side. We're going to take away 4 pebbles from both sides. And we get that x has to be greater than -2. So if you wanted to graph this, we have our number line. We have our 0. We go over here to -2. And then we draw a circle above it. We ask ourselves, can x equal 2? Can it equal 2? No, it has to be greater than. So we leave it open. And if it's greater, it means we have to shade above -2. So this is the solution. This is the graph. Graph of solution. And this is just the solution. Okay. Go ahead and try. Oh, I'll do one more. X minus 6 is less than or equal to 3. Well, what is happening? X is being subtracted by 6. How do we undo this? We add 6. That's a 6. This cancels each other out. We have x less than or equal to 9. We draw a number line. Here's 0. Over here is 9. And this is a good skill for you guys to have. When I draw this, it doesn't really matter how far away I place 9. If I had to place another number, then it would have to be accurate. But if I say that this distance from 0 to 9 is 9, and as long as I label it as 9, that's as much as I need to do. I can't say that right here is 1. That wouldn't make sense. But if I say that from here to here is 9, that's good enough. So we put a circle above 9. We ask ourselves, can x equal 9? Yes, it can. So we fill it in. And then x has to be less than this number. All the numbers less than 9 are to the left. So we shade that way. So that's the graph. That's the solution. Okay, try some on your own. We've got number 1. X minus 2 is less than 3. X minus 6 greater than or equal to 4. And number 3, 10 greater than or equal to x minus 1. Go ahead and pause your video and do these 3 problems, please. Okay, I assume that you've paused your videos. The answer for this one is x less than 5. And the graph would look like, if here is 0, I'm going to say that that is 5. Open circle, shaded to the left. Number 2, x greater than or equal to 10. Here's 0, here's 10. Open, close circle above 10, and then we shade to the right. And for this one, this is a little bit trickier because we have x on the other side. You should always read inequalities from the side that the x is on. So from the x point of view, it's saying that x is smaller than 11. So here's 0, here's 11. Got a closed circle at 11. It's saying that x is the smaller. It has to be smaller than 11. So we would shade that way. Okay. I'm going to do another example like this one up here. And like this one over here. We have 11 is less than or equal to 3 plus x. So what's happening to x? Well, there's 3 more pebbles on this side than there should be. We're trying to find this x. So we're going to subtract 3 from both sides. And we get that 8 is less than or equal to x. Sorry, this is example 2. So we put a 0, we put an 8, and this symbol right here should be read as less than or equal. However, I'm telling you that you should actually read from the side the x is on. So right here, the x is the larger. See how the larger portion of this symbol is facing towards it? It's saying that x is larger than this 8. This should be read as less than or equal. 8 is less than or equal to x. But you should read it from the side that the x is on. So x is greater than or equal to 8. Those are the numbers that are solutions for this inequality. Okay. One other way that you can do this is that no, never mind. I'll just leave it like that. I want you to do page 336. I want you to do numbers 5 through 17. No. I want you to do 5 through 12. And I want you to do 17. Okay. Bye.